today you guys are going to get the opportunity to learn some complex high school level math vocabulary. So these are probably terms you've never heard of before, so I need you to pay very close attention as these terms will come up over and over again this year and beyond. Also, feel free to take notes as you are more likely to remember these terms if you write them down. You could also always reference this video at a later time for a refresher on this important algebra vocabulary. But with that said, let's get started by talking about a new vocabulary term, which is monomial. Now, the prefix mono means one or alone or by itself. So think of like the word monopoly, and monopoly is when one business kind of runs an entire industry, right? Think about the board game Monopoly, where your goal is to be the only one left and you own everything, right? You're the only one there owning all the property. Similarly, you have a term like monotone, which is someone who only has one pitch and talks very boring, kind of like a robot like this, right? Someone who's very monotone has one tone, very flat, doesn't have inflection, doesn't kind of get excited when they talk or kind of sad when they talk. It's kind of just a flat, one-tone speaker. So think mono means one. So if we transition this to monomial, right, we have that prefix of mono meaning one. A monomial is basically a one-term expression. So the examples you see on the chalkboard right now are all examples of monomials. I can tell they are one term because I don't see any addition or subtraction sign anywhere in the expression, okay? Once again, just gonna emphasize this, mono means one, which can also translate to help with developing your vocabulary in general and like ELA, because a lot of words have that prefix of mono, and if you know mono means one, that gets you a little bit of a hint about what the word could mean. Now, when you combine multiple monomials together, you make something called a polynomial. Now, the prefix poly means more than one. So once we start adding or subtracting monomials together, right, we end up with a longer multi-term expression called a polynomial. Now, we will discuss polynomials in detail in a later video because most of this video is actually going to focus still on monomials. But we can get even more specific when we describe monomials and polynomials. For instance, you can categorize monomials based on their degree. So the degree of a monomial, I'm struggling to say that, monomial, is a sum of the exponents of its variables, okay? Now, a non-zero constant has a degree of 0, and the number 0 has no degree. So it doesn't have a degree of 0, it actually has no degree. If this definition is a little bit confusing or doesn't make sense quite yet, it'll make sense, I promise, once you go over some examples. So let's look at this example. And this first example is just the integer -5. -5 is simply a constant. Any constant has a degree of 0. Therefore, -5 has a degree of 0. Any constant, which is a number sitting by itself without a variable, will have a degree of 0, other than 0, which has no degree. Now, it doesn't matter if this number is positive, negative, fraction, decimal, whatever. Any form you can think of. If it is a monomial and it's just a constant, the degree is 0. So -5, 1/2, 7/10, -1,000,000, right? If it's just a constant, the degree is always 0. Now, this next monomial has two variables, but that doesn't make it two terms. It's still one term. There's no addition or subtraction happening, so this is still one term. Now, even though x and y don't technically have exponents written, right? Like they're not visual, they're not clearly written there, this means they both have a power of 1 as their exponent. It's similar to, guys, when you just write like x or y by itself, it means 1x and 1y, but you don't need to write that 1 in front as a coefficient. It's the same idea here. If the exponent doesn't have, if a variable, does not have a exponent visible, the exponent is to the power of 1. So in this case, it means there's technically a 1 on both variables, and 1 plus 1 is 2. So this is an example of a second degree monomial. To recap this process, you simply add the exponents together on the variables to find the degree of a monomial. We can look at one more here. Be careful with this one. The coefficient does not have a degree of 1. The coefficient is not a constant. Those are separate. So that coefficient here, you're not adding that degree. Okay? So you want to only look at the exponents on the variable terms. Coefficient is not the same as a constant. Those are separate. So this monomial has a degree of 3, or is a third degree monomial, because the x has an exponent of 2, whereas the y has an exponent of 1, and 2 and 1 sum together to make 3, making this a third degree or 3 degree monomial. Now, monomials are also sometimes hidden in disguise, meaning you can simplify what looks like a polynomial into a monomial. Now, how do we do this, you ask? It is combining like terms. You guys have the skill down. We've done it over and over again. You just need to apply it to these type of expressions. Now, for instance, these two terms on the chalkboard are like terms and can be combined. Now, how do I know they're like? Well, as a recap, like terms have the same variables and the same powers on, or exponents, on the variables. All right? That second part is incredibly important. Terms are not like unless they have the same exponents and the same variables. You can't have one or the other. Both need to be true. Think about proportional relationships, right? Straight line and through the origin. Same thing here. You need the same variables and the same exponents on those variables. Now, with like terms, all you have to do is add the coefficients in order to simplify. We have been over this numerous times. In this case, what presented itself initially as a two-term polynomial, what looked like to be a two-term polynomial, can actually be simplified down to a single-term, second-degree monomial. Now, the second example, we have a very similar situation. We can add these coefficients again, and these two like terms combine in order to get a single-term, fourth-degree monomial. To recap, we define the terms monomial and polynomial. Monomial, you'll remember because I keep stuttering and messing it up over and over again. But we have monomial and polynomial. With monomial being a single-term expression. We also discussed how to name a monomial in greater detail by stating the degree of the monomial. Last but not least, we discussed monomials in disguise that can be discovered by simply combining like terms, a skill we have worked on at previous grade levels ad nauseum over and over again. In future videos, we will dive deeper into polynomial expressions, but for now, that wraps up this brief introduction to monomials and polynomials.